Saxon Algebra 2, lesson 95. We are cruising along through our last week here before the midterm. Lesson 95 is about more nonlinear systems. When we've done this already, we have dealt with systems of equations that are a little bit more complicated than just our good old linear friends. In the past, we looked at nonlinear systems where we had a circle and a line going through it, and we found two sets of points where the line and the circle intersected. This time we're going to do how many problems? Just two problems, and the shapes that we're combining will be slightly different. I'll explain each one as we go. But that's all that's different, is the types of equations are slightly different. So let's look at example 95.1. And we're asked to solve this system. And this is a line. John tells us that. We don't have to know that. And then he gives us this one. This is a hyperbola. And I'll remind you of that shape in just a second. We're asked to solve this system. Find the point where they intersect. Ooh, look how squishy that is. Now, we don't know exactly what our hyperbola and line look like, but the classic pattern is that we're going to have to find those 2 points, right? This is what a hyperbola looks like. I always think of the black lines on a basketball, you know how they kind of make that shape, and then a line that goes through them. So this is the picture for this system that we're solving. Now, how are we going to solve it? Well, there's different ways we could do it, but what John recommends is that we take this and rearrange it by dividing y from both sides. If this is A and this is B divided, right? Now we're going to substitute B into A. We're going to put this in here. 6 times 4 over y minus y equals 5. Okay, now we're just going to continue on with the solving. This will become then 24 over y minus y equals 5. We want to get rid of this denominator. It is an equation, so we'll multiply each term by that least common multiple. These cancel, but these are all going to stay. So now we have 24 minus y squared equals 5y. Ooh, that looks weird, right? I'm just double checking to make sure. Okay, good. Now, I don't want a minus in front of my y squared. So let's shove everybody to the the right. So it'll be 0 equals positive y squared plus 5y. He will have changed sides. He stays the same. He will have changed sides. So it becomes minus 24. I'm going to carry this to the top of the next page, but what I'm going to do is I'm going to write it with the 0 over there. I'm not swimming anything. I'm just rewriting it. All right, here I was swimming things. Now I'm not going to. I'm just going to write y squared. Okay, kitten. My cat wants in, so you know. Duty calls. Stare out the window while I let my little putty in the house. I'm coming. Good little kitten. It's cold and wet today. You can't expect a little kitten to wait outside till the end of a math lesson. He needs immediate attention. Okay, so we're solving and we've managed to get this system into the shape of a quadratic equation. All right, we'll play along, right? And I think, well, man-eating dragon. But then I think, well, before I resort to that drastic measure, let's just see if maybe we could do it by inspection. And the storm clouds part and the angels sing, because this is x plus 8, x minus 3. Am I right? Oh my gosh, that's fabulous. So now I know that, oh, I'm sorry, it's y. We're solving for y at this point, right? Now I know that either y equals -8 or y equals +3. Those are two solutions. And it kind of makes sense that we're getting two values for y because of my picture, right? I know I do want to have two different points. So now I know that if I want to solve for x, it's 4 over y. So I'm going to write this, x equals 4 over y, x equals 4 over y, and I'm going to use this information to calculate my different x values. So that means x equals 4 over -8, so x equals -1/2. So this pairs with this, and this would be, I'm going to go all the way down here, x equals 4 over 3, so that I don't need to simplify that. All right, so now my final step is to just write these as ordered pairs. So the first pair is -8, -1/2. Oh no, I wrote it wrong, didn't I? Y is second, so it's -1/2, -8, and 4/3, 3. Tricky, right? Because that one, I didn't plan it that way, but that one I ended up solving for y first. So I just had to remember to write them in the correct order. This is the right answer. Let me just double check. Yeah, this is the right answer. Okay? The trickiest part of this whole problem was just facing the fact that we had to create a fraction and then substituting it in. The trickiest part for me was remembering that I'd solve for y, not x, and keeping my letters straight. Okay, we just have one more. And in this one, John tells us that we are solving, I'm going to write them here. A circle and a hyperbola. All right, this is our system. We're calling this one A and this one B. Again, that's just to talk about them. You don't have to write that down if you don't want to. A hyperbola and a circle. That circle is pretty darn good. Can have 4 points of contact, can't it? That means we're solving for 4 points. All right. Well, how do we want to solve this? Last time we had to divide. Now this time we can see, as we just glance down, we see these are both set up as x squared, y squared plain number. And look, the x's cancel. So we're all set up to eliminate. So let's just eliminate. And we get 3x squared equals 3. Divide away that 3, we get x squared equals 1. And that tells us that x equals plus or minus 1. Okay, so now let's make 2 columns. This will be if x equals plus 1, and this will be if x equals minus 1. And then what I like to do sometimes when this is getting more complicated is take one of our equations, and here I'm going to do it in this little space here. We have x squared plus y squared equals 9. I want to solve this for y so that I don't have to do as much algebra every time I want to plug these in. So I'm going to say y squared equals 9 minus x squared. And then I'm going to take the square root of both sides, and I'm going to say y will equal the square root of 9 minus x squared. That will make it easier for me to simplify these. So this is the formula I'm using to solve for my y's. Y will equal the square root of 9 minus, okay, what's x squared? If I plug 1 in for x, that's just 1. That equals 8. And I know that this is 2 cubed, so I can bring out a pair. So it's 2 square root of 2. And because it's the square root, I know I can have the plus or the minus. All right, let's do the same thing over here. Y equals the square root of 9 minus 1 squared. Minus 1 squared, the minus sign gets squared. That becomes 1. This is also 8. So our y value also is going to be plus or negative 2 square root of 2, right? Because that's 2 cubed, pull out a pair. Now we're ready to write our 4 points. When x is equal to 1, I have positive 2 square root of 2. And when x is equal to 1, I also have negative 2 square root of 2. See how I'm using the x's and the y's to create these points. Now I go over here, x is equal to negative 1, y can be positive 2 square root of 2, and also when x is negative 1, y can be negative 2 square root of 2. This, my friends, is our big, fat, crazy answer. And the fact that we're getting the same numbers in all different combinations of positives and negatives makes sense if our circle is centered on the origin. All these points would be positive and negative versions of each other. So this answer fills us with confidence. It's right, by the way, because that makes a lot of sense that we would have positive, negative combinations. This is the end of lesson 95. It's intense. It's a little crazy, but I hope it makes some sense to you. Thank you. Goodbye.